1.1 Solving one and two step equations with pi. So first off, when we look at solving equations, what we do when we want to write down the original problem, and what that does is help us think about, or gives our mind a little bit of chance to think about, ooh, I have this plus 4, and our goal is to get x by itself. So get that variable by itself. Now, you probably already know by number sense that 3 plus 4 is 7, but algebraically, to show that, what we do is we subtract 4 to 0 out. So you see right here, it's kind of 0 plus 0. So we're able to 0 that out. Now, in equations, if you subtract 4 from one side, we have to keep that equality. It's like a balance beam. And if you do it from one side, you have to do it to the other. So it's equal on both sides. So now 7 minus 4 is our solution of 3. So that solution, x equals 3, is solving equations. So example number 2, very similar to that. If we had a subtract 6, then to 0 this side out to get x by itself, we're going to add 6 to both sides of the equation to make it balanced, because we want negative 6 plus 6 zeros out. Now, we do say canceled out, we cancel it out, but it's really, for adding and subtracting, it's zeroing it out, and we're left with x on one side by itself. And over here, 10 plus 6 is 16. And this structure really helps us organize it when it gets a little bit more complicated. So when we take a look at having pi in our problem, which is a little bit more complicated. So if we have h plus 2 pi equals 3 pi. So to 0 out 2 pi, I need to subtract 2 pi. And if I do it to one side, I have to do it to the other. And 2 pi minus 2 pi zeros out, and we're left with h. So I'll bring h down on this side because h is on the left-hand side. Bring down my equals. And 3 pi minus 2 pi. So if you had 3 pi's, and then you ate 2 of those pies, pi, we would be left with 1 pi. And you can leave it this way, but most of the time we know that 1 is so we can think of that as a kind of our invisible 1 out front, and just write down h equals pi. But we're thinking about that invisible 1 in the front. Now, where it gets a little bit more complicated with example number 4 is when we get to multiplying and dividing. So it acts similar but different. So if we have oops, sorry, 1 second. Didn't want to put that parentheses in. So if we start with negative 3/4 x, so this helps me think x is by itself. Oh, I want to get x by itself. So I had this minus this negative 3/4 here. And over here we've got a negative 2. So in thinking about this, I'm thinking about, oh, there is a multiply hidden right here. So we really want to watch out for that. Now, we could, if we wanted to think about undoing multiply, the inverse operation is divide. And if you're multiplying by 3/4, we have to divide by 3/4. Ew, that does not sound like a... And then we could do it on the other side. Now, we can do that, yes. But if we think about what is it that we're trying to do in solving an equation, we want to get x to be by itself right here on the left-hand side. We have this times negative 3/4. And that's why I was putting that parentheses in, is to really help us think about how do we cancel out this fraction. And to cancel it out to be, hey, what number is in front of here? Ooh, that hidden 1 in front of it. So how do we make this negative 3/4 into a 1 by multiplying? Well, we can think about it as multiplying by another fraction. So we have this 3 on the top. So to cancel that 3 on the top to make it a 1, we could put that 3 in the bottom because that will cancel it out. Now, remember, if we do it to one side, we have to do it to the other. So I kind of think of these as doing them at the same time. So I divided this side by 3. Well, that's what in the fraction means. Now, to cancel out the 4 that's in the denominator here, I'm going to put that 4 in the numerator of that fraction to cancel that 4 out. Now, so here I'm multiplying by 4/3, so that means over here I have to multiply by 4/3. Now, we would think that we would be done here because we canceled the 4s out, we canceled the 3s out, or you could think about 3/4 canceling out. Oh, look, it's the inverse where the denominator flips to the top and then the numerator flips to the bottom. We call that the inverse. We don't call it a flip, we call it the inverse, multiplying by the inverse. But we have this positive times a negative is a -1, which we don't want a -1 down there. We want just 1, which is positive. So we also have to multiply by a negative here. So we are going to multiply by that negative to cancel out this positive here, which makes a positive. Negative times a negative is a positive. Now, we just have to simplify this right-hand side. I'll put it over 1, and that'll be negative times a negative is a positive here. So I'll think about that as a positive, and 2 times 4 is 8 in the numerator, and 1 times 3 is 3 in the denominator. So our answer is x equals 8/3. Now, that is a very acceptable answer in algebra. We like improper fractions. They do have to be simplified. So if a 3 could go into both of those, we would want to simplify that down. But an improper fraction is really a very nice number we can use in algebra. So I know a lot of students really enjoy making it into a mixed number because we've practiced that a lot in previous years. So if you switch it to a 2 2/3, that is also a correct answer that you could use. Now, you don't have to. That's not simplifying. It just means that it's in a different form. And sometimes we like the mixed number, and sometimes in math we like the improper fraction. Either of them work well. All right, number 5, example 5. We've got pi x equals 3 pi. Now, I have to really think about this one because there's that hidden multiply. So to undo multiplication, we divide. So we're multiplying by pi, so we divide by pi. If you divide one side by pi, we have to divide the other side by pi. So these pi's, well, I'm thinking in my head, cancels out, but pi divided by itself, any number divided by itself, is 1. So we've got 1x equals, now we can look over here and notice we have also a pi divided by pi. And what's left over? 3 times 1 is 3. Now, where it gets a little bit more complicated is when we have more stuff going on. So 5 pi x, and I'm starting to think about this as being a times equals 15 pi. And I'm gonna, since I see that multiply, I'm gonna divide, do that inverse operation. So I'm multiplying by 5 pi, so I'm going to divide by 5 pi. And if I do it to one side, I have to do it to the other. Cancel the 5s out, cancel the 6 pi's out. By canceling, I mean they're 1. 5 divided by 5 is 1. Pi divided by pi is 1. So x equals 3 pi. Wait a minute. Something's not right here. So if this one is incorrect. Now, this one up here is correct because look at that, pi divided by pi cancels out to be a 1. Did I cancel out my pi over pi? I did my calculating, which I'm really good at, but I want to make sure that I see that pi divided by pi cancels out. So this divide right here, this pi divided by pi cancels out that 3, and we're able to simplify it to x equals 3. Our last example is a 2-step question. So we've got 4x plus 3 pi equals pi. All right, so here I'm thinking, all right, what do I want to get rid of first? And I see I have an operation of multiply, and I also have an operation of add. So we want to undo and move over this 3 pi. So to undo plus 3 pi, we have to subtract 3 pi. If you do it to one side of the equation, we have to do it to the other side of the equation. So that 3 pi's cancel out to be, well, not 1 this time, but it's 0. Any number minus itself is a 0. And over on that left side, we're left with 4 times x equals, now, oh yeah, there's that invisible 1, that hidden 1. So if we have 1 pi minus 3 pi's, we have negative 2 pi's left over. And then to undo this times 4, we cancel it out by dividing 4. If we do it to one side, we have to do it to the other. So the 4 divided by 4 cancels out to be 1x, and notice that it's on the same side. Bring down that equals, and oh, I can see that I've got the 2 and the 4, that's kind of my fraction simplifying. So 2 goes into 2 once, 2 goes into, well, there's a negative, so I don't want to forget about that negative. Negative 1, and 2 goes into 4 twice. So my simplifying, I like to kind of do this way because it really helps me kind of focus on just the 2 that are simplifying. All right, so I've got a negative 1 pi on the top of my fraction, and I've got a 2 in the denominator. So there's a couple places where we could put this negative, and we could put it up here with the top of our fraction, and that is a very good way to do it. That's the way I like to do it a lot of times. Now, the very classic way, and where the textbook has it and anything online, typically they move that negative out to the front, which sometimes get hidden, but we want to see how there's a little space. So this negative gets put out front, and we still have pi on the top and 2 in the denominator. So this one down here is kind of where the textbook will be giving that answer, and this is how we solve 1 and 2 step equations with pi.